Hello, I think we are live, right? I think yes, we are live. As I can see down below 20 seconds we are in. So yes, hello guys. Yes, today we are uh, planning to learn about JavaScript, some JavaScript topics. These are the some topics that we will be learning today. So we will learn today about asynchronous and synchronous function. I mean how the JavaScript works in a synchronous manner and synchronous manner. With our we will understand this via using the async await keywords, and also we will learn about the lexical scoping in JavaScript, and we will end today's session with the learning about closures in JavaScript. So yes, let's start. So I have using ChatGPT, I have prepared some, I would say, notes. So yes, first of all, we will start with the synchronous and asynchronous behavior of JavaScript. As we all know, JavaScript is a single-threaded language, which means it can run a single thread, which means, for example, let's say this is the JavaScript code, and if we learn if we run this code, it will run line by line, and it will not perform any particular line of task in background. Yeah, it means it will run only on single thread. It will not start another process from one script and run it into multiple threads. So this is the overall behavior of JavaScript, which is it is single threaded. And this behavior we called as synchronous JavaScript, which means that the code is execute line by line, one after another, and in coding language we call it a blocking type of code. If the code is in synchronous manner, we call it a blocking code, which means that the code execute after line by line. Yeah, if one line takes time, then everything after that must wait. For example, yeah, in this code, first of all we will console logging start, and after that we are executing this function wait, which have a very heavy time consuming task, which will take few seconds to complete. Until then, we will not uh, further go into our program and console.log end. We will wait until this function task is completed, and then we will at the end we will console log end. So this is the asynchronous behavior, and this is the we call a blocking behavior of the JavaScript, that until the task is completing, everything else must wait. So yes, this is the basic of asynchronous behavior. And coming to the synchronous behavior, we call it, for example, allows code to run in a background without blocking the main thread. So you can say we can overcome the single threadedness of a JavaScript using asynchronous code of JavaScript, which means that the we can run some part of the code in a background, and we call this feature also non-blocking feature of JavaScript, which means JavaScript can start a task like a network request or any other task which takes time consuming task, and we move on, like we do that task in a background, but we move on to the next task. uh, so this is called a non-blocking feature. For example, the non-blocking features or the async features of the JavaScript are use timeout. Use timeout yeah, is a asynchronous code of the JavaScript. For example, if we run set timeout, it will go to the task queue inside our execution, and the next line will be run. Similar to the fetch, promises, async await are the asynchronous examples of the JavaScript. In this example, we can see the asynchronous behavior. So first of all, we will see the start logging out, and here we are setting timeout of 2 seconds, and then console logging inside set timeout. So what will happen is start will print this set timeout will be go to the task queue inside our environment, and this console log end will be executed. After that, after 2 seconds, inside set timeout will execute. As we can see in output, start end and inside this. So what happened here is instead of the blocking code, which is synchronous behavior of JavaScript, we have set this set timeout to the background, which uh, like this task test takes up to 2 seconds to complete, which is like a time-consuming task. So we have set this task in the background. Until then, we have moved on to the next line, and as we have ended after 2 seconds, it will execute this inside set timeout. So as you can see, like we can overcome the synchronous behavior of JavaScript using asynchronous or non-blocking code. So to like the use the asynchronous, there are like two main syntactic keywords in JavaScript, which are like main to learn. These are async await in JavaScript. We will deep dive into it. So what is async? Async function. We use async keyword to assign a function. So if we assign function a async keyword, which means the function return type will be promises. It will return always a promise. Uh, for example, here the function whose return is 42, but as we have assigned the async, it will return full function will return us a promises. Then we can handle the promises using then or catch. So async function, async keyword allows us to assign function a promises. So and what does await used for? Await used for uh, for example, we can await you use await keyword uh, to pause the like I mean we can use await. For example, there is uh, a promise. We can use await to resolve the promise in place. As we can see uh, in this example, we are like getting JSON, which is a async function, which will return promises. Uh, for like in simple words, we use async like await to await where let's say we have a multiple asynchronous like multiple asynchronous functions and statements or function, and we wanna uh, execute them in a synchronous manner. Please note my language, like what I'm saying. It is, I'm saying that if we have a uh, if we have a multiple asynchronous um, I mean functions or the operations, and we wanna execute them in a synchronous fashion. That's where we use await. So using await, what await does is we are using await, we can resolve the promise in place. Uh, for example, let's say we have a multiple asynchronous operation like get data and store data in database. This is the second operation, and third operation is return the success of the uh, like storing data. So we use await keyword by calling get data, and so what await does is it will wait until the get data is resolved. So it will not proceed to the next line until the get data is resolved. It can be like it can be fulfilled or it can be rejected. So because we use await, because the another line which is like storing data, it depends on a get data function. So that's why we use await. Uh, Await like basically blocks. Let me go to the notes. So a sync function returns immediately after pending promises. Execution within function pause at await until promise sum is fulfilled or rejected. As I said, await using await we can we can wait until the promised is promise are resolved. If it is fulfilled, then resolve value. If it is rejected, then it will throw, and we have to catch the error. For example, here, first of all, we will fetch the URL and we will convert the response into JSON. Because of here, uh, response is essential. We will wait until the URL is completely fetched. That's when we move to the next line where we will convert response into JSON. And then we don't want data to be promised. We want data to be the actual value. That's why we use await, we resolve promise here. So we wait until the JSON response.json is converted and then we return data. So basically, what I said, await is basically used when uh, we have multiple asynchronous functions like fetch or convert into JSON. These are the asynchronous feature, and we want to execute them synchronously. As I can say, first of all, we will fetch the data and we will then convert it to the JSON. These are the dependent on each other. That's why we have to execute them synchronously. We cannot first of all convert response into JSON, then fetch the data. That no, na. That's why these are the asynchronous, but we want to execute them in a synchronous manner. That's why we use await. So await help us is await help us to resolve the promises on place. So this is about the async await. And yes, if we are using a sync await anywhere, these are the best practices to use try catch block. So yes, this is the example you can see. And next topic our is lexical scoping. So lexical scoping is In JavaScript, scoping is a convention that determines how the variable are accessed in multiple block scopes. It determines how the variable are accessed in its child scope. For example, let me create a new file, scope.js, lexical scoping. I will write the definition is a convention that allows us how to access the variables in block scopes. This is the lexical scoping basic, I would say, definition. And for example, uh, let f name, let me create a first name, which is chill guy, and let me create a function greet where I will greet the with the first name and execute the greet. So let's see what happened. Mm, No, this, this, scope badges. Oh, I forgot to say. Yes, as we can see, the hello and chill guy. It is not throwing error. Fname is perfectly accessible inside the function block scope. This happened because uh, these are the two different scopes. This is the function scope and this is the global scope. So what lexical scoping allows us to uh, access the variable uh, uh, from different scopes. So the uh, the variable can be passed to its child scope, and child scope can access the variable from its parent scopes. Uh, so what in detail what happens here is let me use the eraser because there I can draw. What happened here? Just let me just use whiteboard. I don't want to log in to whiteboard. Yes. So, in what inside this code happened was So what here happened was uh, when I run this script, so there's something called global execution context happened. So this is the global execution context. Text, where is text? Global execution context. So this is the global execution context happen. Whenever you write any JavaScript or run any JavaScript script, this is happen in the background. So in global execution context, this is the memory phase. This is the memory phase, and this is the code phase. This is the code phase. So here all the variables and the functions are loaded here. So similar to that, when the fname will be loaded here in the G global execution context memory phase. So here fname will be loaded in assignment to the GUI. Also, the as the function have a different scope. So also the greet function will have its own function execution context. We call it function execution context. It will also have the memory phase, and also have the code phase. So what happened here is when the function execution context uh, try to access the fname, which is not in its function execution context. So this is function execution context. So it is not fname is not in a function execution context. So in every execution context, there's something called there is a pointer called scope. So this what does this scope does is this scope refers to its parent. This scope refers to its parent execution context. So what happened here is when the greet function has its own execution context, try to access the fname, which is not in this execution context. So instead of throwing error, it checks with its scope pointer. This scope pointers always point to its parent execution context. In our case, which is global execution context. So if it is not in function execution context, with the help of scope pointer, it will check in its parents. So now fname is in its parent execution context. So then it will use the parent execution context fname. So that's why we will get chill guy here. Uh, and also uh, we can change the fname here to sad guy. This will not throw error because these are the two different contexts and do two different scopes. This is in a global execution context which have a different scope, and this have a different scope. So when we will try to run the script, so we will get a sad guy instead of the chill guy. This happened because we have created a new fname, set it to the sad guy in function execution context. So when we tried to run a function, when it is trying to access the fname, then first of all it will check fname in its own execution context. uh, then it will find the f name and it will refer to it as a sad name. But if it is not in its execution context, it will check in its parents using scope pointer. If it is not in its parent, then this parent will also have its scope pointer parent pointing to its parent. This go on until the global execution context. So this is the lexical scoping works. Uh, for example, as we can see here, we have initialized x with the global string. There's a function uh, uh, where we have initialized x as a outer string. It will not give us error because its scope and context is different, and its scope and context is different. And inside the outer function, we have initialized new inner function, and where we are trying to access the x. So as I have said in this example using this diagram, we will first of all have the global execution context. In his memory phase, we will have x initialized to global. Then inside the function execution context, x will be initialized to outer, and inside that, in inner function execution context, we are trying to access the x. So first of all, x will check the value of x in its own execution context, which is inner function. But as we can see, it is not in its function context, so it will refer to its pointers called scope, which will refer to its parent execution context. So its parent is outer function, and outer function we can see here the outer function of x is outer, so it will return the outer. So we will get the result as outer. But let's say we don't have x referred to here as outer. If we delete this line, if we remove this line, we will get the value of x as a global. Because when we check the here as outer function do not have a value of x, then it will check its parents, which is global execution context, and the global scope have the value of x. That's why we will get global here. If it is this line is not here. So this is called the lexical scoping, which is like convention to access the variable in block scopes. The next topic is closures. So closures in JavaScript is a function that has access to its variable uh, of its outer function even after the outer function has finished executing. In simple words, we can call a function closure function if it is binded to its outer function. We can call a function closure if it is bounded to its outer function. For example, let's say this is the make greeter function and this is the greet function. We are trying to access name inside greet, which is coming from its outer function. So you can say greet is binded to make greeter function. So we can say the greet function is closure. So what happens with the closure is even after the make greet greater function finish executing, as we can see here, make greater stop executing here. Even after it stop executing, its context is still stored in memory. So the value of the name is keep stored in a memory, and we can access or change it using this greet function. as you can see here. Even after the greet is stop executing, we can call the greet alias function and we will get the greet. So this is the closures in simple words. So we use closure for the data privacy and encapsulation. It used to hide a data which is we can set the data to private. For example, let's say closure.js. Let's say we want to create a closure example. We'll create a function called make counter, and here we will initialize count as a let, and we'll return a function which will uh, return the count plus plus. So this is the basic. So we will make counter. So we will make a variable called the make counter. So it will return a this counter will become a function as we are returning function. So this function is a closure because it is accessing its parent variable. So even after the make count is finished executing, it will still keep the memory of a count, its variable, because we are accessing using the function of closure function. So using this we can so this is private variable. We can use closure to make data encapsulation and pass control the processes uh, using the closure functions. But the problem with the closure function is this. Let's say we have a 1 million line of code, 1 million plus line of code here. So uh, our uh, our need of this make counter is over here, but still after using 1 million line of code, we are still maintaining the memory for the count. Let's say it will take us up to 100 MBs of space. So even after 1 million line is completed, our we said we does not need make counter function after that, but still we are containing the 100 MBs of the memory. So this is called a memory leak. Uh, the closures can have a memory leak. So to overcome that, let's say in our code, we are sure that we don't want to use this closure anymore. We can simply set counter to null. So now, as our memory size is 100, we can set it. Now the counter will be like 0, and the memory space will be clear, so it will be null. So this is how we can deal with the closures and its memory leak. So yes, that is it for today. And today we learn about the asynchronous and asynchronous behavior of JavaScript, synchronous and await keywords, lexical scoping, and closures. So yes, this is it for today. Thank you for your time. Bye.